Hello everyone. So in this video we will study about the structural design patterns. Moving on. In this video we will learn the following things about the structural design patterns. What are structural design patterns? How many types of structural design patterns are there? What are the most common use cases of these design patterns in real-world applications of structural design patterns? So we will know about the definition of structural design patterns, what exactly they are and what they do. How many types of structural design patterns, means different types of structural design patterns that we will implement using Typescript. What are the most common use cases of these design patterns, means where and all you can use. What kind of scenarios can arise in which you can use these design patterns. Real world applications, means in what kind of applications you can use, or in certain applications what kind of use cases can arise in which you can use these design patterns. In the end we will have a summary to sum up this video. Right, moving on. So what are structural design patterns? Structural design patterns are the design patterns that help developers discover and implement more convenient ways to establish relationship between objects. Alright, so let me explain this. Let's say there are two objects, object 1 and object 2. So what you want to do is you want to establish a relationship such that you can mutate their behavior and make them usable. So that one thing that you can do is to use the inheritance. You can use the inheritance, and generally it is considered a bad practice. So you will introduce a new class that will have the functionalities of both the objects that you want to establish relationship between, and thereby you can establish relation between two objects without messing up your code by using the inheritance. They create abstractions to facilitate the cross-functional use of entities without introducing extra coupling. Exactly. So you might have abstract interfaces or abstract classes, and let's say there are different functionalities in different objects. When you use inheritance, you might want to create every time a new class that inherits one from the other, and thereby coupling multiple classes, messing up your code. To prevent this, you use the structural design pattern. You will find that these patterns are widely used in the real world, as they allow room for extensibility without sacrificing flexibility. Exactly. What does this mean? This means that you can extensively use structural design patterns your application wide. You can implement multiple features, many complex features, without sacrificing flexibility. Means you are free to make any kind of changes in your objects. You are free to give them any kind of behavior without worrying about how will it impact your application's performance or the behavior. Now let's move on to the next one. What are the types of structural design patterns? So structural design patterns are of following types: adapter pattern, decorator pattern, fake it pattern, composite pattern, proxy pattern, bridge pattern, flyweight pattern. These are the types of structural design patterns that we are going to study in the upcoming videos. There will be a complete playlist for the structural design patterns, as we have for creational design patterns as well. And we will learn the implementations, UML diagram this time as well. And apart from that, we will also see interview questions and advantages and disadvantages, possibly modern implementations as well. So what are the uses of structural design patterns? The use cases: making independently developed class libraries work together. Alright, let's say there are two classes. One is the services class Another is the helper class. In the services class, you have API calls, let's say CRUD operations. And then you have a helper class. You have defined your custom functions for the operations that do not exist in the current programming language. So let's say you have implemented a group by mechanism which does not exist or which is not an inbuilt functionality in the Typescript. You will introduce a helper function for that, or maybe you are implementing the DRY principle. So these two classes are completely independent, but you want them to work together. You will create a new object. I mean, it can be an adapter object or flyweight or whatever. We will study that next. Structural design patterns can be used in this case. Realizing new functionality through object composition. So let's say again you have two objects. Now you need a functionality that requires both of the objects. In this case, it is not recommended to use the inheritance. It is recommended to use the design pattern or a structural design pattern, any one of the structural design patterns that suits your needs. Decoupling and abstraction from its implementation. So there is an abstract interface that has been implemented. You can decouple that. Decoupling means that it is being used at multiple places. So one change in the interface means multiple changes in multiple classes. In this way, using the structural design patterns, you can use one interface for one class, another one for another class, and then you can create a new object that will help compose your two objects, attaching new behaviors to objects. The fourth point, attaching new behaviors to objects means that you already have some functionality. Now there is a change request in which you want to add a new functionality. Now let's say you did not use a structural design pattern. In this case, what happens is that if you had to implement the functionality in the parent class, and then let's say it has relationship with the child class as well, it will kind of mess up your code. You will have to make changes in our constructor, you will have to implement the methods as well, and possibly you will have to make changes in the interfaces as well. So these are the four important ones. There can be more. These are the four important ones at industry level. Now, the real world applications of the structural design patterns. Here, a typical application of this pattern is with a big integer class. So guys, the big integer class means those numbers that are not supported in the integer. These are called as the big integers. This is typically used to represent the mutable arbitrary precision integers and use them to perform calculations. If you are creating lots and lots of big integer objects, then it makes sense to cache the most common ones in memory. This is especially true if you are working with big numbers, as they require more memory than typical numbers. Absolutely. You will see one example here. So this is an example of big int in TypeScript. That is how can you use a big integer. And here what we see is that under the hood, the structural design pattern is being used to implement this object. Alright. Finally, coming to the summary of this video. So we studied about what are structural design patterns, what are the types, when they are used and where they can be used, like when they are used, what are the use cases, where they can be used, what are real world applications. And in the upcoming videos, we shall study about each one of those in detail. We will study all the patterns, adapter pattern, flyweight pattern, restaurant patterns. Thanks for watching. Consider subscribing to the channel for continued content. Thank you. Bye.